Hello, my name is Michael Simon, and I'm going to demonstrate an advanced weather station for my final project EEG for HEW.
This is a weather station project built on the base of Raspberry Pi Model B+, as shown here. The project uses a Raspberry Pi and the ADS1115 external 16-bit analog-to-digital converter, or ADC. The ADS1115 is made by Texas Instruments and interfaced with three different external sensors: a temperature sensor, a humidity sensor, and a wind speed sensor. These sensors produce analog signals. The ADC then converts the analog signals to equivalent digital numbers and transfers the data to the Raspberry Pi through its I2C channel. The Raspberry Pi calculates the equivalent temperature, humidity, and wind speed based on the sensed data, and then sends the values to a remote server via internet for real-time display. The temperature sensor is a National Semiconductor LM35, and it has a precision of 10 millivolts per degree Celsius. The temperature sensor is connected to the first channel of the ADC. The humidity sensor is a Honeywell model HIH 40002, and it is connected to the second channel of the ADC. The default reading of this sensor is the relative humidity, assuming the temperature is at 25 degrees Celsius, but it can be adjusted to provide relative humidity at other temperatures by using an equation provided by the datasheet. This project uses the temperature measured by the LM35 temperature sensor to calculate true humidity. The output of the humidity sensor is connected to a voltage divider circuit. The voltage divider circuit consists of two 100k ohm resistors connected in series between the output and the ground pins of the humidity sensor. The voltage divider circuit provides a safe range of the voltage that cannot exceed 3.3 volts DC for the ADC input to be used on the Raspberry Pi, which runs on 3.3 volts DC. The wind speed sensor is connected to the third channel of the ADC. The ADC converter is defaulted to address 0x48 that is recognized by the Raspberry Pi. The Raspberry Pi also serves as the Apache web server, and it is used as the weather station's control panel, which is built by using PHP. The control panel gives the user the ability to get real-time measurements of the sensors, as presented here. In addition, it can display the sensor's data logged in the database. Moreover, one can set custom conditions when certain weather conditions are met, such as sending an email to a user or running a hardware trigger warning signal, as shown here. The rule set in the control panel is compiled to an executable Python file, and there's a Python application that runs every second to check the rules and execute the trigger if the temperature, humidity, or wind speed meet the set conditions. This project can be used in various conditions and different locations. Each weather station is given a GUID, or a globally unique identifier. A GUID is a 128-bit long number that has little to no chance of repeating. The advantage of a GUID is that in order to generate a unique GUID, one does not need to know about other GUIDs or keep sequence of them. Each weather station sends the measurements online to a central website using its GUID. One can view the logs at the weather stations by going to the Live Devices page and clicking on the cloud next to the device's GUID, shown here. The page will display real-time measurements reported by the weather station, in addition to the past measurements of each weather station as shown here. The unique thing about reporting the measurements to the central website is that the devices do not need special settings in the firewall, and that links to these devices can be set and installed easily anywhere without any special request or accommodation from the existing network. Shown here is one station currently being monitored. The host server on the screen displays a real-time change from this station. Over here, there is a second station, which also has its real-time data displayed. These stations are transmitting their data wirelessly to the internet for display on the host server.